Okay, so the natural base E. E is approximately 2 point... Oh, did we already forget? 2.7183. 2.7183. Let's just go 2.718. I like that. 2.718 kind of has a good ring to it. 2.718. Okay? There it is. It's right here. All of this is like how we find it. Here's some review of exponent rules. I'm skipping all of this stuff. I'm just going to do examples. Okay, example 1. We're just going to simplify the expression. E is just like any old number, any old base. It follows the same rules. If I have e to the 3rd times e to the 6th, what do I do to the exponents? I add them, e to the 9th. Okay? Next one, if I have 16 e to the 5th over 4 e to the 4th. The 16 over 4 is just normal numbers, reduce. And then e to the 5th over to the e to the 4th, what do we do to the exponents? Subtract them, so we get 4e to the 1st. 4e. Yep. It is second. And then on that first column, there is a button that says LN. First column. You see it? Like 3 above on, or 2 above on. Third button up. Do you see it now? Okay. Question C. If we're doing a power of a product, remember everything in here is going to get squared. So I'll have 3 squared. And then when I square this, what do I do to the exponents? What do I do? Starts with an M. Ends in a Y. Multiply, thank you. Oh my gosh. So I'm going to multiply e to the negative 8x. So that'll be 9e to the negative 8x, which would also be 9 over e to the 8x. Okay? When we do graphs with e, which is what we're about to do, we will actually use this version of it. However, this would be more simplified because it doesn't have the negative exponent. When we do graphs, it'll have negative exponents. Okay, I'm going to skip the student practice because that's the chapter we just finished. As long as you know, you do the same stuff with E. So E can have exponential growth and it can have exponential decay, just like the other graphs that you guys did last class. Sorry, I cannot make this stay in the right place. Here we go. Here's an equation right here. It says y equals some number multiplied by e to the rx power. So if r is positive and a is positive, that's what this is saying right here. If a is positive and r is positive, then we've got growth. If a is positive but r is negative, then it's decay. So a has got to be positive for both of these to use this. A is going to be positive for both of these. If r is positive, it's growth. If r is negative, it's decay. So that's a little bit different than what we had done with growth and decay on the last section. But if you look at the graphs, the growth graph looks just like the growth graphs we were doing before. The decay graph looks exactly the same. And then there's the parent functions underneath. The one thing that I want us to do on our calculator really fast is I want us to do e to the -1 power. On your calculator, I want you to do e to the -1. If you don't have a calculator, go to the internet and type in e caret -1. The internet tells you answers. It's very special, magical. By the way, e to the -1 by using the properties of exponents would be the exact same thing as 1 over e, the reciprocal of e. Amar, did you get it? What did you get? Yeah, that's right. You see they have that right here. Okay, so the reciprocal of E is 0.368. We can even make that even easier because you're going to have to graph it. And how accurate can I graph 0.368? Probably my most accurate would be about 0.4 when I graph it. And just even graphing 2.718, I'm not going to be able to graph 2.718. It's going to be more like graphing 2.7. Okay. All right, so here we're going to do some graphs. We're going to say if it's exponential growth or decay, and we're going to graph the function. So if I have an a value that is positive and the number in front of the x is positive, which is a 1, what is this going to be? Growth. How about this next one? Decay. Okay, and it just has to do with that sign that's in the exponent. All right, let's graph the first one. So I'm going to start with my key points, and I like to start with -1, 0, and 1. So I'm just going to do that to e to the x to start. Okay, I'm going to use like transformations. I'm going to do e to the x. So 0, if I plug in 0, e to the 0 is what number? 1. Anything to the 0 power is 1. So every time you use that 0, you're going to get 1. E to the first is 2.7-ish, 2.718. E to the -1, which we just found out, is about 0.4. Now this one has a 3 in front of it. That 3 is not in the exponent, so that 3 is a vertical transformation. That is a stretch by 3. So we're just going to take each of these numbers, multiply by 3. So that'll be 1.2, that'll be 3, and that'll be 8.1. I did that fast because I was thinking of like 27 times 3 is 81. Or 4 times 3 is 12. And then we have an asymptote. What is our asymptote? It's the same that it was before. What is our asymptote? Where is our asymptote is what I mean. Where was it every single time on the first assignment? Y equals 0. So y equals 0. There it goes. I'm going to graph these points. -1, 1.2, 0, 3, and then 1, 8.1. This graph gets closer to the asymptote, it doesn't cross, and that's all you have to do. Okay, so this one I'm going to use e to the -x as my parent function. I'm still going to do -1, 0, and 1. 0 is going to be 1 for the y value. But now, since I'm doing e to the negative x, the -1 and the 1 are flipped. They're switched. So this will be 2.7, and this will be 0.4. Here I have a 0.5. It's part of the exponent, so that means this is a horizontal transformation. It's going to go on the x side. And when we do anything horizontal, do I use the exact same thing? No. This is 0.5, which I'm going to think about being a half. So what will I actually do to my x's if this is a half right here? Do what, Sophie? Multiply by 2. Just do multiply by its reciprocal. So I'll get -2, I'll get 0, and I'll get 2. We still have y equals 0 as our asymptote. -2, 2.7, 0, 1. No, yeah, 0, 1. And then 2 is 0.4. And that one is stretched horizontally, so it's kind of wider. All right, this next section, we're just saying if they're growth or decay. So how about question 4, growth or decay? Growth or decay, go. Oh my gosh, guys. We played a game, come on. Thank you, Joel. Joel, did you get candy for the first game? Okay, I'll give you candy because you yelled that out so nicely. All right, how about the second one? Growth or decay? Decay. Because it's negative up here. Number 6, growth or decay? Growth, good. All right, very last thing. One more formula about interest. You know how we were approaching infinity on our discovery of E? Well, there is interest that compounds continuously, which the number would be infinity. There is a problem like that. Or there, not a problem, but like a situation of that. And if interest is compounded continuously, then we can't put it over infinity. Instead, we have a different formula. It's called the PERT formula. Do you notice it says P-E-R-T, PERT? It's A is the amount, P is the principal, same as before. E is the number we just learned about. R is the rate. And then T is the time in years. So this is where you're going to use that E button on your calculator. Just make sure our interest rate is expressed as a decimal. I'll recopy this formula on this page. It's not P. It's A equals P-E-R-T. PERT. So in this example, we have a graph of your friend's account. I don't know how you got a graph of your friend's interest, their account, but here's a graph of it. And then you have your money in a different account, and your money is modeled by an equation. So they have a graph, you have an equation. Which account has a greater principal? Which account has a greater principal? So that's the initial amount. So let's look at your account. Your account is this equation here. What number is the starting amount in that equation? 4,500. That's your principal. Okay, now let's look at the graph. What is your friend's starting amount? 4,000. Because we look at the time being 0, the year being 0, they started with 4,000. So who had more money to start? You did. Okay, so you had a greater principal. Second question, which has a greater balance after 10 years? So let's do you first. After 10 years, we're going to plug in 10 for T, and you can use your calculator. Jacob, when you get it, will you tell me? Perfect. $6,713.21. So now we got to figure out your friend after 10 years. After 10 years, how much money does your friend have? You just have a picture to look at. So I'm going to go find 10 years. Oops. About 7,000, maybe a little bit higher. But the question is, who has more money? Definitely your friend, because if it's 7,000, which is a low estimate, that's still more than you. Okay, maybe it's even about 72. So it looks like they had the better investment. They got more money in 10 years than you did. Okay, and that's just using the PERT formula. All right, and that's it. Okay, guys.